Coming to you from What's Up Guy Garage. We're actually not going to be in the garage today because we've got another project. In a sense, it's a homeowner friendly project dealing with some copper pipe. Let's go check it out. So while I was working on my garage over the weekend, I've got my garage door open and I turned the heat on a little bit downstairs in my lower level. I basically turned the thermostat all the way to off, and you can hear, because of how close the mechanical room is, you can actually hear the valve close. Kind of thought I heard a drip. So I walked in, I noticed that the floor down here was a little wet. Why is the floor wet? And I saw up here, these pipes that we're looking at right here. This pipe right here, this one, this is my cold feed line. You've got the hot line. And I'll explain why there's this little string and a piece of tape right here. I kept on taking my hand and just wiping on the pipe, trying to find out where I could see the water coming from. So as soon as I would wipe it off, it would just, come back, and I just thought to myself, well, right here, it must be leaking on the seam. Maybe it just wasn't a good solder joint, who knows. And I kept on taking a towel and just wiping on this side. And I could see the water just coming right from this location, but it looked weird. Something about it just didn't look right. And then turning the camera around, I don't know if you can see this right here. This is the elbow for the hot side. The way I discovered that it was actually not the cold side that was the hot side was I finally just put my hand like this. The back side of my hand started getting wet. Honestly, I was just a little confused for a second. It was only a second. If you could take a pin and just prick the pipe with it, just the smallest little hole, it was squirting out a perfect jet hitting that cold side elbow, and it was so messed up. The pipes aren't even really lined up. I mean, they're close, but the cold side is a little bit higher than our hot side, and just the way it was spraying out and hitting that direct joint, like right here. So anyways, so this string right here, this is a wick line. So I knew I wasn't going to get to it right away, so I just wrapped up with tape. Just took this string and I ran it down into a bucket. And the reason why I did that was so that it didn't splash from dripping, from a constant, just like a drip, drip, drip. And the reason why that is because my son's toolbox is like inches away from this issue. And what's amazing is if you line up where the copper pipe is compared to his toolbox, it is literally like 3 inches away. So the amazing thing is that the water didn't go into his new toolbox and mess up his tools. Because, I know I would have been upset myself. So, but anyway, this line, it's designed just to wick the water down. So instead of dripping down into a bucket where it could, create a splash thing, is I'm just going to unwrap this. Some good duct tape here. You can actually see the little spray spitting out right here. Can you see it? That tiny little line right there. You can usually go over to the circuit breaker box that's in your home or in your garage or in your basement, wherever it's located. And you want to make sure that you're cutting power if you've got an electric water heater. We have a gas-fired water heater. It's an indirect fired water heater, so it is getting its heat directly from the boiler. And just shut the switch off that goes to the boiler. People can still use all the facilities in the house except for hot water. You can still flush your toilet, wash your hands. I'd recommend just, keeping it minimal. Sometimes it's better to go ahead and do things when no one's around. That's it. So just make sure that you shut off the power to the water heater however you have to do it. Kill the power however it gets to it. That's it. So just a quick tip. Now remember, you're only dealing with hot side. Crack open the hot side on your faucets. And I did both. Boom. So and then what you could hear, the air being sucked into those spigots or faucets, whatever you want to call them. Just because of gravity. Just grab a hose. Now this is going to serve a dual purpose. And I'll show you what I mean. While I'm already here and I've got to fix that pipe anyway, that elbow, do it yearly or bi-yearly. Flush out your hot water heater. I might as well drain the water heater and get things all cleaned out. So take your hose and go over to your water heater, to the lowest section of the water heater. And usually things are labeled so you can see right on my water heater right here. This is the hot side. So this is what's coming out of your hot water heater. And you look here and this is the cold going into the water heater. And there's a little spigot right here. Now don't get confused with this one. See, I have indirect water heater. So it's actually my boiler that heats the water. So I have two sets of lines going in and out of my water heater. One's coming directly from the boiler. You don't want to touch that one because that's actually a separate coil inside the heater. So the water comes out of my boiler and then goes into the water heater and then obviously just recirculates out. So we're gonna go ahead and hook the hose up. Lowest drain section on the cold side. Make sure it's nice and tight. Don't forget the important step of taking your hose and putting your hose outside. You're gonna crack open this valve. You don't necessarily have to drain your entire water heater. I'm just doing that for the dual purpose of flushing it out at the same time. So for anybody that says, oh, hey, why'd you do that? It is what it is. This is the way I'm doing it. So I might as well take dual advantage of fixing that pipe and flushing out the water heater at the same time. If you want to see what kind of sediment or contaminants are in there, what you do is you just throw it into a clear container, and then when you're all done, you'll be able to see if there are any contaminants that were in your water heater. You can see as I've gone ahead and kind of prepped a little bit. I've got my insulation out of the way. I've got plenty of working room. When you're doing soldering like this, please keep in mind you take everything that you do into your own hands if you're not hiring a qualified technician, whether a plumber or HVAC guy that can do plumbing, whatever. So there's always a process. There's tons of Google videos out there. I just figured I'd throw one on here. What's Up Guy Garage? Showing you how easy it is to get something like this done. Don't be scared. In order to do this job, I'm going to show you the tools and things that I'm going to need or use in the proper preparation of doing a particular job in general. First thing you're going to need, at least for my situation, I do need a 3/4 elbow. Fortunately for me, because I have so much stuff, I already had one. Need some sandpaper. I'm going to use 220 grit. I also have a piece of emery cloth. This is for cleaning the outside and the insides of your pipes. So you can go ahead and get one of these tools. Solder designed for doing copper pipe and water. And I've got some H2O water soluble flux paste, a self-igniting Burns-O-Matic torch head with MAP gas and paper towels. The other thing that I would recommend if you're not used to dealing with a blowtorch or heat or anything like that, get yourself a good pair of gloves that'll take the heat. These are my welding gloves, so these are going to work out perfect. It's not that you need to use Lincoln Electric, welding gloves in order to do copper pipe, but I would definitely recommend just having it on hand. Get yourself some safety glasses. I never was big on safety glasses or hearing protection or gloves or anything like that. I am now. It's never too late, I guess you could say. At least that's what I'm saying. The biggest thing about having a good solder joint is making sure everything is prepped and cleaned. And then once I desolder the pipe that I'm working on, making sure it's fully drained, I'm going to clean those ends after I pull that elbow off, and that will make for a solid joint. So first thing for me is I'm going to go ahead and ream this copper pipe out. And give it a quick little wipe with the paper towel that I've got, just to get any of the other contaminants that may be in there. Give it a little blow. Look at that. Look at how nice and clean that thing looks. That is a thing of beauty. Put your safety glasses on. See? I'll show you. I'm wearing them, okay? So I'm going to go ahead and make things a little bit easier on myself. What I'm going to do, because the plumber was generous with how he did the piping, you can actually see that the pipe is actually kicked over. It's not completely perpendicular. So what I'm going to do is I'm actually going to cut into the pipe that we've got right here. Basically, I'm going to end up making just a new joint. So instead of messing around, This is going to make it easier to sweat these pipes together for me. Not every situation is the same. This particular blowtorch has got an on and off feature here, and what the off does is the off actually locks out the switch so it can't be depressed. So you always want to make sure you turn your valve clockwise to shut it off, counterclockwise to actually turn it on. I'm going to switch this to on, crack it open just a touch, give it a pull. And I want my heat down a little bit. There's also a lock switch that locks it on, which is right here. So when you depress this trigger and ignite it, you can press and hold this down, and that will keep the flame going. So I'm going to use a small pair of channel locks that I've got. And the channel locks are going to go right into the end of the pipe where I cut. And take the blowtorch, as soon as the glass is on, blow, and go ahead and heat up that pipe. Go ahead and at least heat up the joint anyway. Just have patience while doing it. It will loosen up and free up. And then pretty much once it's loose and you can pull it off, go ahead and just kill your heat. You should be able to slide that right off, no problem. So now I'm going to go ahead and take my pipe prep tool, slide it over the copper pipe, and I bottom it out so that it's pretty much almost at the very end of where that copper pipe is. And I'm just going to spin it around. And because I'm right here, I'm going to take the other end and just give it kind of like a brush on the inside. And on this pipe cutter that I've got, it's got a little deburring tool, and I am going to deburr the inside. Keep in mind that this one might be hot. We're just working on it, but it's fine. Just cleaning the inside real quick. Give the outside a nice little clean. Nice. So the other thing with prepping your pipes is using that flux paste. Usually have a brush. Just going to take a little bit of the paste, put it on my finger, and kind of just smear it inside the copper pipe. Just basically on that section where you're going to be soldering both ends. So it's water soluble anyway, so it's no harm. Do the same thing around here. Just take the paste, just kind of prep the surface, and you're good. And then just take your pipe and kind of test fit it on. Give it a nice little spin, make sure it feels good. Do the same thing on the other side. Just give it a little spin. This side might be a little harder just because that's the side that still has a little bit of coating of solder on it already. Just make sure I coat it just a little bit again. And I'll go ahead and slide this on. Slide that on into there. And that is literally there. Get out your solder. Roll a good amount out, say about 5-6 inches. In some cases it kind of varies how people do solder, and I am doing it my way. So what I'm going to do is I'm going to apply heat to this joint, and on the opposite side of that joint, or pretty close to it, I'm just going to start to touch the solder. Let's see if I can get the camera up there. Just show you what I'm going to do. So I'm going to apply heat to this section of the pipe right here at this joint. I'm not going to really heat this pipe. I'm more concerned about heating this joint right here, or this section of pipe. And the solder is going to go pretty much on the top, almost at that opposite angle. And I'm just going to lightly just kind of drag it right across, and what will happen is the solder will draw into the joint. And that's just how it works. And I'll do the same thing on this side. I'll heat probably this section here, and then again, just draw the solder onto that section right there, and that's it. That's why you use a glove too, because if you use a glove that can support heat, as you're wiping these joints down, you make them nice and clean. So if after flushing your hot water heater and you go to turn your valve off and you get this, a drip, what that means is that the seal that's on the back side of that valve has probably eroded. I'm not going to say corroded, I'm going to say eroded because of the way it's designed. So what we're going to do is we're going to take this valve apart and see if we can just replace that. If we can't, I will have to go ahead and get a new valve at the big box store. So I'm not worried about the fact that it's leaking still. It's a 32 millimeter, and that's actually going to fit right on that side, I'll say the tank side of my unit. Put a pipe wrench on the other side. The only tough part is that there really isn't much room here. So the key is just to kind of break it free. I don't want to mess up the threads in the valve, but whatever. Give it a twist. We'll get to a point where you can just do it by hand. Yep. Everything can be fixed. It's just, do you have the time or are you prepared kind of thing, I guess. So this is the fun part about doing your own stuff, I guess, in a way. Is that sometimes if you're not fully prepared, it'll take a little bit longer. Obviously, if you called a plumber, he would most likely have, or she would most likely have everything that they needed. See in there. So that little piece is replaceable. So we're going to go ahead and take this apart. See if I can avoid a trip to the big box store. And I'll show you what you need, because I've got them. So this is potentially what we need. Flat washers and a screw. And that's literally all it is. So inside there, you can see what's happened to the seal. The seal actually broke away. So what we're going to do is take this valve apart and replace that seal. Again, it's pretty easy. Don't be scared. Normally I'd just go ahead and use a vise, my bench vise, just to hold on to the valve, but I'm going to do it if someone didn't have a bench vise, like a homeowner type of deal or whatever. So it's kind of always a good idea to have one of these flat washer assortments. There's just all different types of sizes. They fit multiple different styles of faucet valves, and obviously you can see, or at least I'll show you, that one of these is definitely going to fit that valve right there. So, but this is your typical brass valve that you find, 3/4 inch. And what I'm going to do is I'm going to put a 1-inch wrench on this side. And so this little piece has packing in it. And what packing does is it kind of pinches a material that's inside of this valve so that this can still freely turn but not leak. Where I got that term from was when I used to paint cars. So on this particular one, I used an 18 mil just to break this free, which this is where the packing is inside. And that all that's doing is, I don't need to do anything as far as this valve is concerned, or this little section, but I do need to get this piece out of the way so that I can get a good bite on that. So place it down on the ground, 11/16 on that other side, and I'm just going to crack it open. And you can see it's unscrewing. And this is just so that you don't have to make a run. I mean, you don't need to. Things like these types of valves, if you analyze it, you can pretty much see that this stuff can come apart, and you can probably replace the insides. So take that off, and you can see that on the seam right there, now it's free, and now you can just spin this off, and there you go. Now it's open. Alright, so you can see this isn't going to work. But still, I'm going to leave this video up. It shows that sometimes, maybe just not in this case, that these parts can be replaceable. I could go ahead and... Actually, you know what? Let me see if I get one. This goes onto here, and then you got this flat washer goes there, and then this screw will go right into that hole right there, but this is all broken. So, I'm going to take this piece, which this is a 1/2 inch valve, it's a T-style valve, and I'm going to see if this piece right here will work inside this piece. So now when you look at the two together, you can pretty much see that they are really close to each other. So we're going to check it out. So, it's that 18 mil on there. Get that wrench on. Break it free. And then we're just going to unscrew it. That, nice. We can compare the two. We can see with that little shoulder piece on there, it's a little bit more stout. So I think this is going to work. Some of the things that you typically run into. So in this style valve, this shaft with these flat sections, it's a thinner shaft. So I had to take a file, and I just basically filed down all 4 sides so that the original handle could fit on. So I put the flash on this time so we can actually see this valve working. So there's its fully retracted position. And then as we close it, you can see that it fully seals. Right there. Perfect. That works. That's all it needs to do. This is just a drain valve, so it's no big deal. And then what I can do is, like I said, that every 1 or 2 years that you should be draining your water heater, what I'll do is I'll just go ahead and just get another one of these valves, and I'll have the part and I'll leave it right on top. That works. We took a valve apart that was a 1/2 inch T valve, scavenged the parts, but that works. That's why I keep stuff. That's why I hold on to stuff. And this isn't, anything major. It's just a drain valve. It's just draining the water out of the water heater when you flush it. So that's it. So I guess it's kind of like always handy things that you can have around the house. This right here, and this is just thread tape. And the thing about thread tape, they have I think a thread paste and a thread tape. I usually use a thread tape, but I've got so much of this that this is what I'm going to use. So when you think about how the valve goes in, you're turning it clockwise, and that's to spin it in. So it's like that righty-tighty, lefty-loosey. So that applies for this valve as well. So with these threads right here, what you want to make sure you do is when you do put this plumber's tape on it, or thread tape, that you want to wrap it actually the opposite way. And the reason why is because you're spinning the threads in this way. If you wrap the tape the same way that you're spinning in the threads, what's going to happen is it's going to want to have a tendency to kind of peel it off. I mean, to me it's common sense, but I mean, somebody might not know that. So, just going to wrap it up. And just a couple wraps. That's all it takes. And just be careful with what you're doing. Let's see if I can do this without it being in the way. I think some people call that liquid stuff pipe dope, is I'm pretty sure what it's called. So I'm not going to torque this down just yet. I'll show you why. Because I don't want to crank this so hard that I bust out any of the solder here in this joint, or mess up anything that's going on inside the water heater itself. We'll go 33. And remember how when you do this, when you put this valve back in, you want to make sure you do kind of leave it at a little bit of an angle, and that way it just makes it easier. So when you hook up your hose, that you're giving yourself room, that you're giving yourself, you know, that proper angle, and not sticking it all the way to the ground or whatever. Go ahead and tighten this up. Just turn on the water real quick, the supply line. Now what I did is I just put enough water in it, we could check to see if it was leaking, and it's not, so it's working out. So just go ahead and turn that valve back on. That's your cold water supply line. Or leave some of the faucets open. That way all the air can evacuate out of the lines. And once all the air, or just about all the air, is gone out of those lines, don't forget to, after you pressurize the system, to go ahead and check, you know, see if there are any leaks or see if there are any issues, and then go ahead and switch that switch on or to your electrical panel. Whichever way you've got it going, everything should be good to go. So obviously, in a way, the last steps, you already know what they are. You just clean up. Pick up your mess, make sure you don't leave anything behind, and that's it. What's up, Guy Garage? Don't be scared.